Hi, my name is Bhomik Patel, and this is my Artificial Intelligence Foundation coursework about flood risk predictions. And in this project, I built a small machine learning model that tries to predict how likely a flood is based on different factors like monsoon intensity, drainage, deforestation, and urbanization. And in this video, I'll quickly show my notebook explaining the data and modules I used, what result I got, and then talk about some problems and real life issues with this kind of AI system. So, if I explain my module, at the top of my notebook, you can see all the libraries I used, and I used pandas and numpy to handle the data, and matplotlib and seaborn to make basic plots. I use scikit scikit-learn for splitting the data and scaling it and creating different regression models like linear regression, decision tree, and random forest, gradient boosting, and supporting vector regressions. And I also use X plus XGBoost and some error metric such as mean square error, squared error, mean absolute error, and R square. Then I load my database from a file called flood.csv into a pandas data frame, and each row is one example with a bunch of risk factors, and last column called flood is probability is the value I want to predict. Some of the input features are things like monsoon intensity, top, topographic drainage, river management, deforestation, urbanization, and drain drainage system, and also coastal value vulnerability, and other columns related to infrastructure and planning. I first look at the head of the database, and then I use the describe function to summarize and check the average, mean, max, and square of each feature, so I know the date I know how the data look normal. And after that, I split the data into features and the targets. All the column expect the flood probability are stored in X, and the flood probability is stored in Y. And I use the train test split to divide the data into training and test sets. And also for some models I also use a scalar, so the feature value are on a similar range, which can help the performance. And then in the project I try several regression model instead of just one, a simple linear regression as a baseline, and then try tree based model like decision tree, random forest, and the gradient boosting plus XGBoost, and support vector regression for each model. I fit in the I fit in on the training data. It make predictions on on the test data and calculate metric like mean squared error, mean absolute error, and R square, so I can compare with one which one works the best for me. And when I compare the scores, the tree based Tree-based ensemble model like random forest or gradient boost usually perform better than the simple linear regression because they can learn more complex nonlinear relationships between the risk factor and the flood probability. From the feature importance of these models, I can also see which factor matters the most. For example, strong monsoon intensity, weak drainage system, and high urbanization, which makes sense in real life. And during this work, I face some issues and limits. So let's talk about it first. The database is clean and simple, which help me the model, but in real world data is usually much messier. I also had to handle libraries versions and training time for models like XGBoost and do some basic turning to avoid overfitting. Another limitation is that the data doesn't include any location or time information, which is very important for real time forecasting, like real time forecasting. There are also commercial and ethical points which I want to add. And and if I talk about it, if someone uses a model like this with a poor or limited data, they use they could underestimate the flood risk, and they make bad planning or investment in decisions that that can affect the infrastructure, insurance, or people safety. So it's important to be honest about how model was trained, how accurate it is, and to treat it as a support tool, not a perfect answer. And at the end, if I want to conclude my point, so that's what I build, and the results. Now to wrap up my ICA, in this ICA I created an AI model that predicts probability, like it predicts flood probability using several environmental and human related features. And I tested different regression algorithm on the database. I showed how I loaded and explored the data, prepared it for modeling, training manipulation models, and compared their performance using standard metrics, which enables model to give the best result in my experiments. I also looked at which features are most important for flood risk and discussed and I discussed the main limitation of the database and models, plus some real world risk and ethical points if a system like this is used in practice. So overall, this work helped me understand how AI techniques can support flood risk prediction, but also why careful data selection, model evaluation, and human expert judgments are still very important. So thank you for watching my walkthrough video.